last session for the day.
Thank you.
We have a very interesting short talk by Sibesh. He is the founder and head of Hyperloop India. His team has built India's first Hyperloop prototype, which is planned for the Hyperloop corridor in the Mumbai, Bangalore, Chennai area. So I invite Sibesh to be on stage. He is not going to be talking about Hyperloop in general, but it's a multimodal transit using ubiquitous standards for seamless transportation and connectivity. So welcome, Sibesh.
Thanks. Yeah, sure. Hi, everybody. I'm Sibesh. My presentation. So I'm going to be talking about, I'm the founder and team lead of Team Hyperloop India. We work on this on-demand public high-speed transit solution called the Hyperloop, which was first proposed by Elon Musk in 2013. So what my talk is going to be today about is more about something called multimodal transit. Now, there's a lot of discussion, so this affects sort of all of us. Whenever we travel from, say, home to work, we don't use a single form of transit. We use multiple forms of transit. So, for instance, you take a bus to the metro station, and then you take the metro station from origin to destination, and then from the destination you take, say, an auto to your work. And it's a pity that these modes of transit aren't really connected to each other in any way. So, what I'm going to be talking to you about is how achieving multimodal transit between modes is sort of a first step towards building the foundation for something like the Hyperloop, and how we sort of came to that realization and what we are doing about it. So what sort of scope does this hold? Now imagine if you could connect different modes of transport together. So say a bus is connected to the metro, or a metro is connected to a car. You could share different sort of data between each other, and you could store them. You could sort of create a memory or a backbone on public transit, which could sort of help it learn and adapt to the mobility patterns of the city. Now this has wide implications. What if you could share the average occupancy of a vehicle or an average occupancy of a car with different forms of transit? And these things could work together in order to sort of get more people into fewer vehicles and get more people off the road. Now, a lot of people who are exploring connected vehicles, but if you actually go out and look at Bangalore, what you actually need is fewer number of vehicles. I mean, that's the need of the hour. So I'm going to first describe what the Hyperloop was. So, so Elon Musk sort of proposed this new concept, a fifth mode of transport, back in 2013. And how this essentially works is there's a bunch of pods, packetized pods, which travel inside vacuum tubes at really, really high speeds of around 700 miles per hour. And this they can achieve because they are magnetically levitated, and so they have no contact friction. And also they are passing through semi-vacuum, which means there's very little aerodynamic drag. And of course it's public transit, so it's not a bulk form of transportation where you have a train which is carrying 1,000 people at the same time. You have a packetized form of transportation, so 30 people at a time, so that you can balance supply and demand, and you can make it on demand, depending on how many people actually want it. So Elon Musk sort of threw open this competition back in 2015 when we started, where he challenged teams all over the world to build a pod prototype, a Hyperloop pod prototype, and he built this 1 mile track, and he challenged them to sort of come and build vehicles to race on this track. And we were one of the only team sort of only Indian team which sort of tried to do that, and we sort of built a Hyperloop pod prototype, and we sort of drummed up this sort of wave of nationalistic competitive impulse. And in around 2.5 months, we built this 4 meter by 1 meter by 1 meter sort of prototype, which actually magnetically levitates, and shipped it halfway across the world to LA and actually raced it on the SpaceX track, and it magnetically levitated. So for a long time, we were sort of dealing with the Hyperloop as an engineering problem, as a problem of maglev, as a problem of vacuum transit, as a problem of engineering. But the engineering is sort of a very small part of the problem. The Hyperloop is something that's going to exist in the next 20 years, 25 years, and a lot of problems with public transit need to be solved before one can actually get to that stage. So in the course of our journey, where we created a Hyperloop study between Mumbai, Bangalore, Chennai, and we also created this big stakeholder network of public bodies, private bodies, government bodies, which would actually help accelerate something like the Hyperloop in the future. We discovered that the high-speed maglev and vacuum tube-based problem is just a single problem. There are many, many other problems with building something as huge and infrastructure heavy as the Hyperloop in India. One of the biggest things is engaging with the government. Now, no one single private company can just come and bulldoze their way and build a Hyperloop. There are a lot of other problems, like it's completely new technology, so there is no way to regulate it at this point. There is no successful track record. The value capture models are sort of very skewed because you plan to get people from one city to another at the fare of a bus ticket. So the subsidized cost to that extent require very, very sophisticated value capture models. But the most important part and the most important problem that is sort of limiting something like the Hyperloop from coming into India is the lack of multimodal connectivity. And what this means is, I'll quickly give a quick example. When you come from Delhi to Bangalore, it takes around 2.5 hours by flight. But from the airport to any destination, it takes the same time. That's very, very ridiculous. I mean, that's not how transport should work. Your last mile and the first mile is as important a part of your journey as your middle mile. And just taking people really, really fast using vacuum tubes and maglev transport from A to B is not enough. And a quick concept I'd like to introduce out here is the value of travel time savings. Now, in multimodal logistics, this is a big issue because every single minute and every single hour counts in logistics, and it translates directly into monetary savings. We don't think of ourselves in the same way, where every single minute we save in commuting from home to work is a minute that we save. It translates into a monetary value. And that's what we are trying to do. We're trying to solve multimodal connectivity, where one can go from doorstep to doorstep as seamlessly as possible by switching from transit modes. And the reason this is part of this theme is because you're connecting different transit modes together, not different cars together. I'm quickly going to explore how we are trying to do this. So from focusing on the high-speed maglev and vacuum tube-based part, we started focusing more on the on-demand packetized direct-to-destination part of public transit. And how we tried to do that was we changed our mission statement to accelerate the advent of widespread shared mobility by creating this sort of end-to-end public transit experience which is compelling enough. Now, why this is important is because if you look at Bangalore city today, in the last 5 years, we've added 3 million cars but just 2 million people. This is not a good sustainable way for any city to grow, and that's why we have increasing transit problems. Now, making public transit a compelling experience is important to offer people that alternative experience to car usage, which makes them shift from car usage and use public transit instead. And so, hence we decided to focus our goals on creating on-demand public transit with current public transit systems first, and then see how this sort of paves the foundation for something as radical as the Hyperloop sort of 20 years down the line. And how it works is that we divide your transit into sort of three modes, and each is a pickup mode and a transit mode and a drop-off mode. And your pickup mode, and all you have to do is you have to enter your destination, and you just have to tap a button, and the whole thing sort of takes care of your whole ride completely end to end, and not just in terms of information. So it's not just Google Maps, but it actually hails the ride for you at the right time, and it calculates what is the fastest way to go from end to end destination using public transit as a backbone. Now the major problem with public transit is that it's very, very impervious to new technology. It's very, very impervious to private enterprise. And so our sort of approach to this is sort of to take it to, in the words of Sun Tzu, to take it it's a pincer attack, where we first attack the last mile and the first mile, and introduce our technologies to the last mile and the first mile, and then use that and the technology that we have for multimodal transit to integrate seamlessly with the public transit experience. And our first pilot we secured as part of the Station Access Mobility Program with Bangalore Metro, which is good news. So if we succeed, then we should be able to create an on-demand, end-to-end, doorstep-to-doorstep public transit experience, which is much, much better than a car. Now, the competitive landscape for something like this is something that I'd like to draw people's attention to. Now, this is what the sort of ride-sharing market looks like. And at the end, as you can see, the columns are average vehicle occupancy, on-demand convenience, multimodal connectivity, and public transit network effects. And multimodal connectivity is an issue that no one in the market is currently dealing with. And I'll quickly go about how and why this is important. So there are currently three different blocks that sort of constitute what multimodal connectivity is. So first is infrastructure and operational integration, right? So how do you seamlessly go from, say, an auto ride to a metro ride? And how can this operationally join with each other? How can you have carriageways and parking spaces at the metro station so that autos can park or buses can park, and you can seamlessly just get off and go, and you don't have to worry at any point of time about there being any operational blockages at these touch points of transit. Then is information integration. So when you want to go from place to place, what are the schedules, what are the routes, what is the occupancy of each vehicle, what is the fare of each vehicle? All this is valuable information that helps people plan their route from place A to place B. And the third thing is payment integration. Right now, from mode to mode, you have to pay the auto by cash, and then you have to take a smart card and do the metro, and then maybe then you have to go to the bus, and then you have to pay by cash again. There is no sort of seamless integration of sort of payment. It does exist in a lot of other cities where they have unified transport planning bodies, but where you don't have unified transport planning bodies like Bangalore, this payment integration system does not exist. So what sort of solutions do exist? So you have transit info apps, which sort of just give you information of how to go from place to place. But information is sort of single use. Information gives you no control over what is the quality of service or or any service guarantees. It doesn't get you on time. Like beautifully presented information doesn't make inferior public transit better. Then you have contactless smart card in places like Singapore and Japan and London. And while they help you with payment integration, they don't help you with information integration or operational integration. So that part is missing. Then you have mobile payments, where you can use a mobile phone to make payments at different points of transit. And while this offers, and the problem with these is that they use technologies which require a lot of friction in pairing up, or they require special hardware like NFC. They're not really ubiquitous, so they're not really standardized across different phones, and especially for a place like India, they require internet connectivity, and they don't work on legacy phones. So mobile payments are, again, inferior choice. Then you have ride hailing and live tracking, which is sort of the information part of it. They have real-time GPS updates, they have control over the supply and demand, they have control over the quality, but they don't really integrate with public transit the way we'd like to. What if you could bring the sort of advantages of all these together to sort of create a service which takes care of all three: information, infra, and payments. And so for the first time, the technology is here to do that, and we call it data over sound. Now, how you usually, back in the old days, how you used to usually transport using transit is you used to talk to people, you used to talk to the conductor and tell him where to go. But what if, or you used to go to the auto and tell that auto where to go. But what if that could happen between devices, not between people, but between devices instead? And the important thing is that when it happens between people, that's a very high bandwidth, low bandwidth sort of way of communicating. But if it happens between devices can talk to each other between modes of transport, between modes of transport across the city. They can talk to the cloud. They can talk across the city, sort of adapt and learn from the movements of people and the movements of the city to sort of adapt the modes of transport to how the city performs. So, for instance, if people won't want to ply along a certain route for a bus, then the transport mode can learn and adapt and reroute the transport mode along a route where people want to travel. So this is called the Internet of Sound, where you're actually using this technology called data over sound. You're using small ultrasonic inaudible beeps to communicate between devices. And why this is a new sort of protocol that has recently come. It's mostly being used in payment apps, but it's sort of never being used in mobility to sort of transform how we travel from one mode to another. And why it's sort of revolutionary is because this sort of works ubiquitously. Like every phone has a speaker and a microphone. And this can work between any two devices with a speaker and a microphone. You don't need an NFC, you don't need Bluetooth, you don't need any pairing between devices. It can work in limited internet connectivity, which is the sort of which is one of the limitations of public transit, and it can work perfectly in a country like India, where internet connectivity is a bad problem. It can work with legacy phones, so old people, kids, everyone can use it because you just need a speaker and a microphone to communicate between two devices. So you can see the demo out here. There's a check-in device and the ticket device, and none of them are connected to the internet. And you just play a small file, which is an audio file. It's completely inaudible. And the iPad automatically detects what that a signal is being sent. And the powerful thing about this is that it's a very low infrastructure cost device. So I'll give you a quick perspective. The Metro Transit Authority of New York is recently spending around $400 million in completely changing their entire infrastructure from a smart card-based system to a mobile-based system. And it's taking them $400 million because it's a lot of specialist infrastructure. But what if you could do that with infrastructure which like devices which already exist, like an iPad or a phone? That brings down the cost by 100x, and that's a huge improvement that could help transit agencies all around the world transition from a manual or a card-based ticketing infrastructure to a mobile infrastructure where anyone could load their card anytime and could get information updates anytime between modes of transit. So here's an example of how this would work. So say you're at home and you have your phone along with you. You just go and you go to the auto, and the auto wala has a phone or two. And the moment you do that, the auto wala knows exactly where to go. So he takes you to the metro station, and the metro turnstile also has a device on it. So you tap the button again, and the devices communicate with each other. And then they already know where to go. So it's just one single mobile phone that you have to use from switching from right to right. And the interesting thing is, if you just go back to the origin, what you can actually do is, because these transit modes are connected to each other, they are communicating with each other. So the moment you tap the button at the origin station, the auto or the vehicle at the destination station knows that you're going to come in 10 minutes, you're going to come in 15 minutes. So it doesn't have to stand at the station and congest the station. It can be positioned far away, and it can just arrive at the moment you're going to arrive, pick you up, and take you to your destination. Another thing that can happen is multiple people who are traveling in the metro who are connected via this system. Our system can sort of bunch people traveling to the same place together and sort of allocate them to the same auto or the same bus, so that it's a very on-demand experience, and you can drop them right at the doorstep instead of them having to go through this fragmented experience of going to a bus stop and then walking to their destination or so on. So this is the sort of fundamental advantage of connecting different modes of transit together via the sort of ecosystem that you're trying to create. So then you go to the destination station, then you go to the auto at the station, the same tap protocol handshake happens again, and this takes you to your final destination. So it's a doorstep-to-doorstep way of traveling from home to work using public transit. And because public transit is already fast and affordable, it becomes the most desirable, fastest, and affordable way from traveling home to work. So why would you use a car instead? And the market out here is completely underserved. Like, it's a $4 billion market. The public transit space is completely devoid of any cashless transactions or any information options. And it's a completely underserved space, and that's what we're trying to exploit out here. A case two would be when you're taking an auto to the metro station, and then you're taking when you reach the station, you have a bus there, and the bus already knows where you have to go. So the bus doesn't have to ply along certain routes. It's already been told when you are at the origin station where you want to go. So the bus already knows where you want to go. It can drop you directly at your doorstep. This is the sort of $5 billion market. And then you have a case three where you might have cycles at the station. And all of these are communicating via this single protocol of ultrasonic handshakes. So you have auto which goes to the station, and then you have the transit, and then at the end station you can just tap the button near one of the cycles of the fleet, and then you can go and drop off the cycle right at your work. So the most exciting part about this is how this sort of transitions back to what I was saying in the beginning, is how this sort of transition into building the Hyperloop. And how I see the exciting sort of future to be is that Uh, this is another use case of the same technology. It's the same ecosystem of devices being mounted on the transit side and on the vehicle side to sort of facilitate this doorstep to doorstep experience. And in the future, what you would have sort of 20 years down the line is this same pickup drop-off transit scheme, but with the pickup being the metro and the Hyperloop sort of facilitating the intercity way of traveling where the transit becomes your Hyperloop and then your drop-off becomes a bus or something. And this sort of helps you get that save costs and time from home to work. And that's what we're sort of trying to achieve. So how do you get involved with this? So you can pilot with us. If you have employees going from home to work every day, you can talk to us and help us sort of improve our service better and build up on it. You can partner with us as investors or strategy and to keep and sort of eye on this technology and how it's sort of increasing and how it sort of can developing and how it can help you in the future. Or you can join us and help us develop this technology further. So I'd like to just end up on a note. A developed country is not one where the poor can afford cars, but one where the rich use public transportation. And this is something we fundamentally believe in, and what we try to achieve in the future with multimodal transit and the Hyperloop. Thank you. Yeah, sure. Yeah.
Hello. Okay. Just to share with you, we started a carpool.com in 2006 in Delhi. Wanted to share, the people share rides based on SMS service, did not work because people were not ready to do that. Two, first of all, concept is very elaborating and very good. But just to give you some negative connotations of it, I did a MTech thesis on integration of card with Delhi Metro, DTC, and also private operators. There's no single agency which could come out as a private collection operator because 3 people did not join. Okay, so integration of modes in terms of multimodal transport is a big issue. Currently, even the Ministry of Urban Transport has not been able to solve it.
Yes.
So I'm putting the perspective right. You can give me one example in this country which has multimodal transport and payment collection system? Answer is no. Okay? Cochin Metro is trying it. It has succeeded to some extent to get into the local transportation because of the Kerala government initiative, but it has not worked completely. So my only take is conceptually very right, but it has its own challenges. Plus, look at the physical infrastructure you're trying to put in. I'm pretty sure it's not going to come. Okay? So, okay. The tube and all these things are a distant future. The timing which you mentioned on these issues, please, I know you can ask many presentations from me and I can give you any number of presentations on this. The seamless connectivity is an ideal situation. It will not happen here because no auto is allowed to stand here anytime. No waiting, no time. If he gets another passenger, he will move around. So question is, all these are issues. Please bring into these problems into your solution set, then it might work.
Yes.
But the concept on a sound note is very good.
Right. So, please, right. Please. So I'll quickly break that down. So first of all, about the Hyperloop infrastructure, right? So that is something that's going to happen 20 years, 25 years down the line. And it's definitely going to happen when it's successful in some other country like Dubai, where a sheikh wants a Hyperloop right there and he builds it. Yes. Yeah. So essentially, the Hyperloop infrastructure is a completely different different problem altogether. Now the infrastructure of multimodal connectivity. Now, what you're trying to say is that definitely there's no multimodal connectivity that exists now, and it mostly exists in places where they have a unified transport authority. Colombia, London, Japan, Singapore, a lot of places have unified transport planning authorities, and major problems which they encounter is profit sharing, where one agency can't share profit with another agency because they're completely different. So they can't plan with each other, they can't share profits with each other. But if you use this technology where you have a very, very low infrastructure cost of just setting up these devices on the transit mode, and you have a completely offline way of transaction where a bus can register what users it has, and then it can upload that information to the cloud the moment the day ends. It doesn't have to continuously do it. So this offline way of transacting and this offline way of information transfer, I think that's happened in mobility for the first time, and that is something that is interesting and and we're already piloting this with BMRCL. So, I mean, we need to see what options we can see in the future and how this can sort of scale up to Kochi, Delhi, Bangalore, Hyderabad, or all these cities developing metro in the future.
So thanks, Sibesh.
Yeah.
We need to stop here.
Yeah.
Thanks a lot. Thank a lot.
Oh yeah, sorry.
In fact, I would request Sandeep to come over and give a token of appreciation to Sibesh.
Please, you've done a wonderful job, but be cautious about it.
Yes, definitely. Yes.
Urban transport is a very dirty word.
Yep. Work. Definitely.